It was an easy mistake to make.
Did I get the company wrong? I'm sorry, Julian. I apologize.
Okay.
Yeah, it's quite all right. Can everyone see my screen then? The presentation anyway?
That's good.
Yeah, I should say GraphQL Federation.
Yep.
Perfect. All right, yeah, as Dan mentioned, I'm the senior engineer for Two's Complement, consulting agency in Boulder. Basically work on all sorts of different projects from cryptocurrency to regular, well, to design, to regular web apps, to native apps, a little bit of everything. So my talk will not be nearly as deep or interesting, but I thought I would go over something on just GraphQL in general and a way to connect your microservices together seamlessly and reduce your overall sort of attack surface just by having everything come through one gateway. So I'm kind of under the assumption that everyone has some basic understanding of GraphQL. If not, I'm willing to answer any questions on the inner workings at the end of this. But one of the key things to tie this back to Ruby is sort of is a convention over convenience, where the convention sort of defines the standard and defines what developers should do, putting into a good spot for development and for structure and creating a general contract that everyone can abide by. So you won't see any Ruby code throughout this because there's no specific kind of code that ties you to GraphQL. GraphQL is the interface, and you can use any code to use it, and then it can connect you to basically any data source, from REST to databases to document stores, S3, whatever you want. It's just a in-between interface. So GraphQL Federation. The idea is that it combines GraphQL APIs from multiple microservices together. So if you take a look at, say, Uber's got what, like 1,000 different teams and microservices that they all connect together. And it's just a way of structuring your architecture and even your organization to make modules out of the different parts that make up your application. It's a way to better manage it and give stronger ownership to each team who manages it and develops for it. And this is a way to connect all of those services together into one cohesive endpoint that, say, the mobile app will access. So with regular GraphQL, this is possible to combine all these together. It's usually done by a process called schema stitching. And it's previously been a manual way to connect all the other GraphQL endpoints together into one endpoint. It basically goes like, I'm going to pull from this endpoint and stitch together. So there's some good things about it, and the key here is that Federation doesn't lose any of the good bits from schema stitching. It's able to merge together remote APIs just by pulling together the schemas and doing that manual merging process. You can also add custom resolvers to these remote APIs. So you can pull from one API that's supposed to load user data and then amend it to include other parts of the user. You can override pieces of the APIs if you want to, say, hide the password field or extend the password field to then transmute it for other internal use. You could do that as well. You could transform the entire API. You could rename data types. You could add your own types to sort of augment the user. maybe user has user posts or user position. You can extend it in all those different ways. And that's sort of one of the nice benefits of this, is you're able to have this one API that does users, and it all comes together into one focal point. In this case, it's the GraphQL proxy. So if you consider that a user has an ID and name, and that's the core of it, it's just the data from one data source. And we want to have, say, in this case, posts and mentions from a whole different data source, different table, different API. It all comes together at the GraphQL proxy or the GraphQL gateway. In this case, we can also pull in from a third-party REST API quite seamlessly using the same GraphQL interface. And that's one of the big advantages that GraphQL affords us, is you have one interface, one way of accessing data, and you don't really care how you get the data and what's going on in the background. Usually one GraphQL query could spin off 1,000 other queries to different services, and it comes back and you just get your one query result with all the data there, and you don't really care what it went through to make it. So in this case, there's a process of how do you go about stitching. So as I mentioned before, you pull the schemas from all these different data sources together, and then, so that's the introspection part. That's, even Federation is called introspection, where you query the other endpoint, pull in the schema, and then mash it up together. And within that, you have to mitigate collisions, any kind of data types that have the same names. And then you have to connect and relate the entities. So the user doesn't have any relation or idea of the mentions field, and you're going to have to relate that in the gateway. And that's how stitching works, is there are connectors in the gateway itself that go ahead and make these connections.
Julian, sorry, real quick. Are you advancing slides, or are you still kind of on the GraphQL, like kind of the overview?
I was advancing slides.
Okay, because we're not seeing the slides change, just so you know.
All right.
Zoom for the win. Oh, there it is. There's a change.
Yeah, let's just go back to regular Zoom then.
Is this, you're trying, Julia?
So yeah, instead of being too fancy, apparently.
Yeah, we've been having a lot of problems with it at work.
It looks cool when everyone else uses it, but I guess when I use it, not nearly as cool. All right, let's go back to Federation and just kind of go through the slides, so you guys can read kind of what we went over as far as the Federation combining different APIs. And the previous way was through schema stitching. And of course, the good pieces about schema stitching: merge together APIs, add custom resolvers, override extending existing APIs, transform those APIs, and extend them. And then the probably only picture and the pretty photo of the typical schema stitched GraphQL gateway, where you have the user and the mentions going out to a completely different service, and a third-party API where you're pulling in your profile photo from, say, Facebook or whatnot. The process, of course, is introspection, pulling in the data, the schema, from these APIs, merging them together, adding the connections, basically the relationships between them, telling the system or the gateway how to figure out what the user API needs to get mentions, or what the mentions needs from the user type to get the mentions. And then, of course, resolving types and subtypes, which is kind of a way to consider relations or subrelations or transmutations in the way of If you wanted to, say, take first name and last name and make it into just a name and concatenate the two, you could resolve that into a derived type. So the downsides probably be pretty big. As I mentioned, with stitching, there's code in the gateway itself to handle these relations, to make these relations possible. And this can become fairly obscure as you add, say, 1,000 services. They're all that code is in there and mashed together, saying this is related to this, and this is how you resolve this subfield on this type. And it can get pretty difficult to understand and read and maintain after a while. And of course, the hidden pitfall within all this are the unspoken dependencies that are created within the gateway that neither backend service knows about. So all of a sudden, users is tied to mentions, but users or mentions, neither of them really know about this dependency. So if they go and they're developing and they change fields, naturally something will break within the gateway. And since the gateway is the one point of access, then everything goes down. And this invisible dependency structure just keeps growing as you had more and more relations, and as you're just picking and choosing fields, which then you use to relate the two types and relations together. So, very big downfall. Now, if we look at GraphQL Federation, it changes the whole structure by making this whole thing convention-based. And the way that we do this is services define their own contracts. They say, so the user will say, this is my ID, my user ID, and this is what you can use to key off of. This is a primary key. It's not going anywhere. And this is what you're going to use. This is what we're making available for you to use. Everything else we'll do whatever we want with. If we're iterating and we're going to add 1,000 different aliases for a person's name, we can do that, and it shouldn't affect anything you were doing. This also means that since you're defining your contract, there's no real dependency between you and the gateway and the other services. You're saying, this is my API interface, basically. So when the other service then decides that they want to extend your service, they just implement that contract and you're good to go. That's the only thing they need to know about you, and you don't need to know anything about them. You could be extended by 1,000 other services and there's no real direct dependency there. So the good pieces of Federation, it's super, super easy to understand and implement, as you will see in a few moments. Like, unbelievably easy. It's really easy to scale and deploy, adding more gateways as you need it. The gateways just, there's not as much. Very, very little at the gateway compared to the schema stitching days. There's less dependency and coupling between services, so it becomes easier to develop features and innovate without breaking the connections between different services. It's also incrementally adoptable, which is probably one of the better benefits of this, in that if you have this giant monolith that you need or want to migrate, you can just put one model, one piece at a time into the Federation system, and it'll work perfectly fine that way. Even if you're using GraphQL currently, or using REST or whatever, if you're using GraphQL, you can have the rest of it on your traditional GraphQL gateway and run the Federation and slowly migrate things over. As I mentioned before, it's implementation independent in that it's not tied to Ruby, it's not tied to any data source, it's just the interface. And this modularity gives it the ability to be easily modified and develop in parallel. So the process, how is this different from schema stitching? How is it different from sourcing the schema from 1,000 different sources, different APIs, mashing them together, creating resolvers and connections within the gateway, How is it any different? It's actually quite a bit different. You have type references and type extensions, and this comes about using GraphQL directives. And that's basically it. So the GraphQL server themselves, they generate the individual schema, and it's able to operate independently. So the user service and system is a GraphQL service in itself, and you can access it directly if you need to. But as I mentioned before, it has contracts, and is defining the primary keys that you can use to access it and extend it. And that's all it does. So they're all standalone, and they all come together at the gateway. And the only thing the gateway needs is just a list of the services. So when you first create your federated gateway, it's basically just going to be initialize gateway, list of services, 5 different endpoints, and that's it. You're good to go. So what does this look like? We'll go over some simple GraphQL type definitions. So we'll take this from the perspective of a books API. Let's say it's from Amazon, because all they do is books. Type book. Normally, this would not have the directive @key or @key fields, ISBN, or ID. The fields ISBN and fields ID are federated directives that define the primary keys on how to access a book object. So imagine this data type without those fields, and that's what it normally looks like. And with federation, you're adding a definition for the primary key with @key and then whatever keys you want. So in this case, we're defining 2 keys that make this book uniquely identifiable: the ID and the ISBN. So if you're building the books API, this is all you really need to make your service available and extendable to the rest of the world. Now let's take a look at the book API as from the perspective of the reviews API. So you're writing a review for a book, but the book API doesn't necessarily know anything about reviews, or doesn't need to care anything about reviews. So we're going to take the book type, and we're going to create a stub of the book type. We're going to extend it. So the first is the extend directive. Allows you to extend the book type, and then we're going to define the field. So before we defined the same field with key fields, ID, ISBN, and now we're adding the same directive in the review API in the type in the review API called ISBN fields. And then we're defining the ISBN field as external. So this is a shell of the original data type. You'll notice it doesn't have title, doesn't have ID, it just has ISBN. So it's only defining the pieces that it cares about from that data type, and it's identifying which pieces are external. So the external and the key identify that primary key that it's indexing off of. So when you're accessing a review, or you're keying a review in your table, or if you're still using a relational database, you're going to have the primary key be the ISBN, or at the very least index to the point where you can look up your reviews by the ISBN. So in this case, we're extending the book data type to add a list of reviews. So when you have the resolver within the reviews API, it's going to be passed the ISBN, which you can then pass your database to look up all the reviews for matching that ISBN, return all of that, and that's it. Now whenever you look up a book, you can also pull in the reviews, and the GraphQL endpoint will then proxy part the request to the book API, part to the reviews API. Both will come back in parallel and return to you the combination of the data. You can also access books through review, but that's a traditional GraphQL feature anyway. As I mentioned before, you have derived fields and sort of transforming. This one introduces a third directive called requires. So everything for extending the book within the reviews API is exactly the same as before. We're keying off the ISBN. The only difference is we are now adding a requirement that we have a title field as well. Now, the title field was not exported as a primary key or as an index key or as a uniquely identifiable field for a book. But here it's being declared as external because the book extended version in reviews needs the title. And the field formatted title as this directive called requires fields title. And what that means is when the gateway sends a request off for the formatted title to the reviews API, it's going to pass that title as well. So it's going to query the book, get the title, and then pass it to the reviews API, and then get back the formatted title. So with this, you can transform, modulate, derive values from any existing values. The only downside is the ones that are defined here can only be defined within the existing data type. So within the books API, it cannot be defined in some third-party extended book version. It has to be the original API for you to be able to extend it using this method. So finally, the bad about GraphQL Federation is nothing is perfect. In this case, it does not support subscriptions, whereas the traditional GraphQL model supports subscriptions where you can create an open connection using WebSockets and just get data as it comes back. That's the only downside to using Federation. Overall, it makes development a lot easier and it reduces coupling and promotes separation of concerns and modularity. Any questions?
I had a question real quick. I noticed that well, actually, one of my questions was, and I'm definitely not a GraphQL like even newbie, right? But so in the first case where you have the review API which extends the type book, when you are asking for a review and you get back a book, will the book have the ID in it, even though it wasn't? I mean, does extension mean I'm going to add fields, or does extension mean I'm extending this kind of type and I'm kind of redefining the fields that are available?
So the bottom type review, where it has a list of books, is assuming that you're starting from a review object. So let's say you request a list of reviews and you want to get the books as well. There's some key on say the review object that will tie the two together, and it will then send that over to the books API query, probably an individual query per book, but yeah, it'll send it over to the books API and you'll get back all the data, because there is a query planner that kind of plans out what data needs to go to each service in order to get data back that you need.
Okay. So books will probably, when you query for reviews, you'll probably get back like a list of ISBNs, because that's what reviews knows about, right? And then it will send that to the books API, and the books API will inflate those objects with kind of all the other attributes of books and send it back. Is that basically how it goes?
Right, you'll get back the full data type for the book. You have access to everything. And then of course you can do silly, stupid things like, of course, since book has a list of reviews, you can then query back to reviews from within the book and just create this, crazy loop, which is also one of the downsides of surfacing a GraphQL API to the public, is while it does afford you a great deal of flexibility, it affords you also a great deal of stupidity.
Thanks.
Julian, I don't know if this is beyond the scope or where this kind of falls, but let's say, and if I'm understanding correctly, you're reaching out to two APIs What if they're external? What happens if like one doesn't return, like with a timeout or something? And then how does this coalesce into a response or an error?
It sort of depends on the data type. If you're pulling a book item, and if the book is non-nullable, it will throw a GraphQL error. But if it is nullable, it will return null for that value, and probably also an error, but it might not fail entirely.
Okay.
Yeah, if the service is missing, you will usually get an error or a list of errors as far as the things that have failed, the queries, and the parts of the queries that have failed.
All right. So you'll get return values from your API that you would then handle when you're parsing it, but it's likely not gonna blow up the entire response. So you could still do some things.
Yeah, you'll still get a response, but you'll also get back an error.
Yeah. Okay.
And then, of course, if the data type doesn't match, because GraphQL is basically strongly typed. So in this case, if say we were pulling back, let's say if ISBN was a field that we could query from a remote something, since it's non-nullable, and if it failed, then the whole thing would fail because ISBN cannot be null. So it still has to adhere to the types that you specify within GraphQL.
Gotcha. Okay.
I was curious, Julian, when you're, is this a topology you've done in production?
Yes.
When you were combining these multiple APIs, were they running in the same data center or are they external to the data center?
We have some, it's a bit of a hybrid. There are a few new GraphQL APIs which run Federation, which interweave seamlessly into the entire system. And then there are of course, legacy APIs which run REST. So we've then created a GraphQL interface to them back to the gateway. So they appear as full-fledged GraphQL interfaces and APIs. And then of course, there are third-party external APIs as well that we make REST calls out to. And those we just create a similar GraphQL sort of abstraction layer. And they all work fairly well together.
Gotcha. So your performance story is obviously dependent on like what parts of the API you're stitching together. So you're basically paying the price of the slowest, least reliable member of the party, attendee of the party on every request.
Right. I mean, when you start the query, you also have a query plan that's built out where it determines what's required for each successive query. Because if you're going to query, say, a review and you need books, you may need the book IDs first. You have to go to the book service. It's going to create a query plan for each subsection, and it will likely end up spitting out several requests anyway. So it's not necessarily going to be the speediest thing because you're going to be running many HTTP requests all at once. And some of them might be very slow.
If you're not storing any of these, right? So you're trying to not have a database. Is that one of the benefits to doing this?
As far as storing what?
Like a local database, not API centric, like because you have GraphQL services, you're not storing books, you're not storing reviews, correct?
Right. We don't have to. These
Okay.
can live entirely on a separate data source somewhere else. It can live on S3. It can live basically wherever you want.
Okay. Okay. And I see what you're saying with the calls. That's okay. Thank you.
The reason I asked the performance question, Julian, is that, so I'm an engineer at GitHub, and we are moving away from GraphQL because we, after many years, have yet to be able to get it to be as performant as we want it to be, despite trying some of these strategies. And I'm curious. I would love to hear about this being performant in practice, because we're finding that performance is just like such a criteria for architectures these days, that like GraphQL solved so many problems for us, but it didn't solve the most important one.
I'm curious how they handle like a failure too, because if they have if you can control all if they're on the same data center, what you were saying, it's so easy to say, okay, well, this service is down, let's fix it really quick. But if something's down for a day, or if you have two calls that rely on each other, I'm curious how you handle that.
Well, the failure doesn't, if one of 1,000 services is down, the gateway itself does not fail entirely. If you have this one request that ends up touching that data source that's failed, that request will fail. But that's the nature of integrating with any third-party service. As far as performance goes, it's probably not the ideal scenario to have REST or GraphQL requests running around within the data center. Ideally, you'd have some sort of gRPC running interference between the services to make this as fast as possible. And overall, GraphQL is not perhaps the most efficient way to communicate between services, since, as I mentioned before, if you were to query the review and the books and whatnot, it may send out 1,000 different sub requests for each book saying, I need this book for this ID, this book for this ID, and then you just get this like storm of requests within your network. So it can be particularly unperformant.
Are you doing this, into the performance question, are you doing this on top of Rails, or is this on top of Node?
We currently use it on top of Node.
Okay. So to Joel, to your question, we moved in the performance case, like when you pair it with Node, we found it's way more performant than it ever was on any other stack.
So you aren't using Rails, Chris?
We are, but we have a gatekeeper. So GraphQL as the central gatekeeper on top of Node. Node upgrades and GraphQL upgrade at the exact same time in the open source community. So all the bugs go over there last, whereas if Rails or any other version was way behind. So it just seems to work. And in our case, it's performant. It actually works pretty well, but that's all Node does. It like just handles GraphQL requests and then it pipes it over to the Rails monolith.
Do you guys have like, did you say you have like some kind of a like preprocessor or something that's just querying all the services and then just spitting them back out in a, I don't know, some kind of JSON file or something, and then your Rails app just picks it up?
Was that to Chris?
Yeah.
Yeah.
Yep.
Oh, sorry, I didn't know it was. No, so it's kind of like what Netflix does, or I think Airbnb does something similar, where it's just a central gateway and then it matches it, right? So it'll collect all that data points from the back end.
Yeah,
So you could scale them independently is what you can do. So and Node's really good at asynchronous communication, and then Node pairs with GraphQL very, very well. If you take, so what we had tried first before I joined was GraphQL was on top. I tried it going from on top of Ruby, and it wasn't performant, number one, and then number two, it would like our updates or patches for it, nothing was getting in. So it just took forever to get that package upgraded. So they just switched it entirely over to match what the front end JavaScript community does, and then a lot of those problems went away.
So are you using GraphQL to communicate between the services as well?
Yeah, yeah. We basically used it as the central API. Everything goes into that, and then it goes to the other services behind it, and then everything comes back through it.
Oh, it's nice to know that.
So in our case, to be clear, like we match. So you're talking, we use resolvers, right? So we match the resolver to a endpoint. So it's not traditional REST, as you would say. So we're not really following strict REST. It's more of like it matches to what the GraphQL resolver needs, and then those resolvers then mash up all the. It's really good. GraphQL is really good at mashing up all those different collections and putting it out whatever the front end desires at that point in time.
Right. And of course, Apollo also provides managed GraphQL Federation where all your schemas kind of go up into the cloud and you can use their gateway as your main gateway point. You also get some schema validation there, which is kind of nice. And alternatively, there's Prisma, which is also fairly lovely because it just sort of generates your ORM as well. So if you wanted to connect it to like Mongo or Postgres or S3, it all works seamlessly through Prisma. So when you create the types like this, it will also generate the resolvers and the actual ORM to access each of the entities and perform queries and mutations on them by default. Any other questions? Everyone has mastered GraphQL. I love it.
It's an excellent presentation. We know it all now.
Yes. Awesome. Well, thank you.
Yeah, thank you, Julian. I think that's about it for us. Thanks again to Yam and Julian. Super appreciate y'all. Dan had to bounce. The new perspectives are always welcome, both technology and current events and technology. So super enlightening. Appreciate it. Does anybody else have anything else before we sign off? All right, Joel, you can probably kill recording, and everyone have a